Hello, 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 my dear warriors. Am I audible, visible to all of you? Do let me know in the chat box. Guys, I'm so sorry. I was talking in some other class, or maybe I was just talking and I completed some 10 minutes of the class. And then I realized that I'm not live thanks to somebody's message, Gopinath, and so many others. Thank you so much for putting it up. I just realized that I was not live. Anyways, so let's redo the class. Let's start it again. Just 5 10 minutes I did it. So let's redo it. Good evening, my dear warriors. This is your captain Shreyas, and we are going to complete this chapter of units, dimensions, and errors we did in the first class. What is units, physical quantities, derived quantities, dimension analysis, and their applications. Today we'll complete errors, significant figures, and the two major instruments, which is screw gauge and Vernier Caliper. Okay, that's what we're going to do today with your captain Shreyas, your physics master teacher who has been training, guiding, mentoring students, thousands just like you for more than 12 years, guys. And now it's your turn to get mentored under me, and it's very important that you find the right mentor and the right channel, because that's when you have that motivation, that's when you understand the subject properly and you understand the realities, or else you will keep dreaming that this will happen, that will happen, and that never happens. So I'm so glad that you found this channel and found me. And give a small Guru Dakshina by smashing that like button and also subscribing to the channel. And good evening, Pratibha, Pavitra, Gopinath, Krishna. Nice to see you all back. Hello, Saranya, Sushmita. Hi, Dream. Hello, hello, Harborine. Hello, everyone. Good evening. Good evening, Abdul. Abdul's birthday is also there today. Wow. Too good, too good, too good. Awesome, awesome. All the warrior pandus are full of energy. Wow, look at that fire. Look at that fire. Pandus WBW. Thank you so much. Thank you so much. Let's get started with the class. And I started teaching also because I thought I was live, but I was not. Okay, so let me tell you this. Has it happened that you are in a family meeting, you're in a family meeting or some cousins meet up or some elders are talking, some important discussion is happening, and then that little Pandu or you go and say that, hey, listen, I have an idea, we can do it like this. And you just completely get ignored. You're like, hey, what are you saying? Get lost. You go and study. And this person listens, oh, this person is elder, I will listen to him. Oh, this person, he's always right. Oh, this person, I have to always listen to him, he's my friend. So these people are significant in that discussion. You, that little Pandu, are completely insignificant. Nobody cares. You might have faced that issue, right? It hurts a lot. I too faced it. 100% Senorita, 700 plus with this channel alone. You don't have to go anywhere else. Hello, Jay. Yes. Hello, Visha. Yep. You have faced that issue, right? Okay, great. Yes, 100%. So same thing happens with numbers also. So imagine Pandu writes 007 joules. Then realize that this 0 and this 0 are of no use. Why are you even writing it? There is no use of it. You can just might as well write it as just 7. So this number 7 is the digit which is important. Those two zeros are not important. But maybe I write those zeros somewhere else, then maybe then it becomes important. Like for example, if I write 7007, then obviously those zeros have some value. They change the value of that particular number which is written here. Even this, and this, all of them now become important. So where you write it, how you write these digits matters a lot. And that's why we're going to see some rules for these significant figures. So significant figures means basically your digits of importance. Digits of importance. Okay. Those are the digits which are significant, meaning of importance. And these digits of importance exactly decide how precise the value or the measurement is. How precise the value or the measurement is. And remember, whenever you add, subtract, multiply, you have to take into account these significant figures if you are a proper scientist, engineer, medical practitioner. Just chumma putting, sir, I calculated I got 72.006532. If you write it Chumba like this without understanding how it works, some of these digits may not even be correct. But Chumba, you're writing it just because the calculator is showing so. So sometimes you need to follow these rules so that it actually makes sense, whatever calculations you are doing. Okay. So, hello Neha. Yep. Yep. So let's see what those rules are. The rules are very simple. All the non-zero digits are significant. All the zeros that occur between any two non-zeros are significant. Okay. All zeros that are on the right of a decimal point, and okay, we'll come to this. But first, let's talk about these two rules. First, let's talk about these two rules. Okay. I'm talking about the first two rules for now. Okay. Let's talk about the first two rules. This one and this one. So what it means is, imagine you have a number like 2305, or you have the number like 4561. All the non-zero digits are always significant. You can see this is non-zero, 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 non-zero. 1, 2, 3, 4. So this has basically 4 significant digits. 1, 2, 3. All of them are non-zero, but like this rule says, all the zeros that occur between any two non-zero digits are basically significant digits. They automatically become significant. If you don't write the zero, the value will change. 235 is way different from 2305. So that zero is becoming significant. So this also has 4 significant figures. Even if I write something like this, 50.008. Okay, so then obviously this 5 is significant, this 8 is significant, the zeros, whether decimal is there or not, it's between two significant digits. So they become automatically significant. So this has 5 significant figures. That's how this rule works. As simple as that. Okay, so all non-zeros are significant and zeros in between are automatically significant. If I put a number like 2060.0807. How many significant digits are there in this? This 2, 6, 8 and 7 are automatically significant because they are non-zero. Anything between them, 1, 2, this and this are also significant. So 1, 2, 3, 4, 5, 6, 7, 8. So this has 8 significant figures. How many of you wrote 8? Very good. Awesome. Awesome, my dear warriors. Very good, Pavitra answered it first. The next important rule is basically regarding the decimal places. All the zeros that are on the right of a decimal point and to the left of a non-zero digit. This is the decimal point, so to the right of it, but to the left of the first non-zero digit, they are all non-significant. They are never significant. Okay, so you can see these zeros are after decimal before the first non-zero. They are not significant. Don't count them. That is the rule. And all the zeros on the right of a decimal point are significant only if a non-zero digit does not follow them. Like this one consists of 4 significant figures. So you will see that anything after the decimal, right? If you put zeros, then you will count them as significant figures. Before that, there should be at least one non-zero number. It should be followed by a non-zero number or before that, then they are counted as significant. So let me explain this to you. Let me explain this particular rule and this particular rule to all of you using certain examples. Imagine I put the number like 0.0567. Whenever you have a 0 after the decimal and before the first non-zero digit, this is the first non-zero digit, they are definitely not significant. So this and this are significant. The moment this is not significant, this also automatically becomes insignificant. So hence this has exactly 3 significant figures. Similarly, if I had the number like 0.00203005, then how many significant digits does it have? Anytime you have a non-zero, they become significant. Any zero between two significants will automatically become significant. These two zeros are to the right of the decimal, left of the first non-zero number. So automatically they become insignificant. So does this. All these zeros become insignificant. So this has 1, 2, 3, 4, 5, 6. So this has 6 significant figures. Exactly. This has 6 significant figures. Similarly, we can take more examples. Let's understand this rule also. Let's understand this particular rule also. So, in this rule, basically any zero after the right of the decimal point, they automatically become significant. So you will see this over here. Say for example, I write it as 5.000. The reason why I have put a decimal and 3 zeros is because I know precisely till the third decimal that it is this much. I'm just not sure what is there next. So that is why these zeros become significant. Hence, this 5, including these zeros, which are followed by this non-zero number, which are followed by the non-zero number after the decimal, they become significant. So hence it has 4 significant figures. They have been followed after the non-zero number. We can have more examples over here. Let's take this 2070.00. How many significant figures does it have? Well, this 2 and 7 definitely significant. This 0 is between these two, so definitely significant. These decimal places are after the non-zero numbers, so they are significant. Anything in between automatically becomes significant. So 1, 2, 3, 4, 5, 6. So this has 6 significant figures. This has 6 significant figures. Similarly, if I write something like this, 9,908.02050. How many significant figures does this have? 9825 significant. This also becomes significant, and so does this, because this is between two non-zeros. This is also between two non-zeros. These two zeros towards the end are after the decimal, so they become significant. They become significant. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My goodness, it has 10 significant figures. It has 10 significant figures. What about this, guys? If I just write the number 7 point, what is this number going to have? How many significant figures does it have? Or let's say, for example, 80850 point. How many significant figures does this have? How many significant figures does this have? This one, this decimal, there is nothing after it, no zero. So this 7 is a significant digit. That's it. So it has exactly 1 significant figure. There is no zero after it, but there is a decimal. That means I'm sure of this 0 as well. So this, and this, all of them are significant. So 1, 2, 3, 4, 5. So this has 5 significant figures. This has 5 significant figures. Exactly. Very nice. Very nice. What about this? If I just write 80700, how many significant figures does this have? Or let's say the same thing if I did not put decimal. So it became 80850. Now things are slightly different, my dear warriors. This 885 and this 0 is significant, but this 0 is insignificant. So do not count it because there is no decimal later on. So only 4 significant figures is there in this particular problem. Only 4 significant figures. Yes. Yeah. Is that clear? This 0 is between two non-zeros, and 1, 2, 3 non-zero numbers. This 0 is no longer significant. That's how it works. These are the rules. Now all the zeros that are on the right of the last non-zero digit are also significant. I think this, I explained it over here only. We took this example. These zeros are also going to be significant. So this rule is also indirectly done. All the zeros on the right of the last non-zero digit are significant if they come from a measurement. Basically, there is a unit. And also there is one more rule. Powers of 10 are insignificant. I need to put that. Powers of 10 are insignificant. Powers of 10 are basically insignificant. Very, very important. So let me explain this rule as well as this rule by taking some examples for all of you. If I write the number 253 into 10 to the power 3, this is like saying 253 1, 2, 3 zeros. Remember, this, and this are significant. This are significant. These zeros are insignificant, so is this power of 10. Hence, the number of significant digits in this one is just 3. Is just 3. As simple as that. Very good. It's clear. Awesomeness. Similarly, let's say I write the number 20.00 into 10 to the power 7. Then how many significant figures are there? Let's have a look. This too is significant. This power of 10, 100% not significant. Then whenever there is a decimal and it is followed after a non-zero number, these zeros become significant. Anything in between also is significant. So this has exactly 4 significant figures. Now, if I write the number like 700, okay, how many significant figures are there? This 7 is significant, whereas these zeros are not followed by decimal, nothing special, nothing, they are not in between anything, so they are insignificant. So this has basically 1 significant figure. But there is a catch. If I write this as 700 seconds, 700 meters, then remember all the zeros become significant, and then it has 3 significant figures. If it is followed by a unit, then it becomes significant. That is the rule. Okay, I hope everything is slowly clear now. Everything is slowly clear. Let's take a random example of finding the significant figures. I'm hoping you're going to tell me the answers really quick. Okay, let's see. 20.070300 into 10 to the power minus 5. Count the number of significant figures quickly. Okay. 50300 meters. Next, 1.0090 into 10 to the power 3. 0.005006. Count the number of significant figures in all of them. Come on, my dear warriors, what is the first answer for this? This, of course, this 0, this 0, this 0, even these 2 zeros are after the decimal. 1, 2, 3, 4, 5, 6, 7, 8. So this has 8 significant figures. I can see the spam 8 in the chat box. Very proud of all of you. What about this? It's followed by a unit. So this, all are significant. So this has exactly 5 significant figures. Awesomeness. How about this? The powers of 10 are always neglected. 1, 9. This 0 is after the decimal. So count it. So 1, 2, 3, 4, 5. So this has 5 significant figures. What about this? These 2 are non-zeros. These 2 zeros are between them. Never count the zeros before the decimal if it is not followed by a non-zero number. So only 4 significant figures. Very proud of all of you. Awesome. So now you get any kind of question, I'm pretty sure you will be able to do this. You get any kind of question, you will be able to find the significant figures, my dear warriors. Yes or no? Shreyas Sir has taught you. Okay. So let's go to the next part, which is rounding off, because no, generally you will not find the number of significant figures in any question. Very, very, very unusual. If you get a question, find significant figures, you will find the final answer to the right significant figures. That's why this counting is very important. It's just like saying in NEET exam, sir, will there be a question to add to numbers, sir? 28 plus 7, sir. Will the question come, sir? Yes, the answer is 35, sir. Will that question come? Obviously, it will not come. Nobody is going to give. Fine, NEET 2025 question paper, 28 plus 7. But addition is used. Same way, significant figures are used. Nobody will generally ask you a question, find the significant figures. Okay. So, the next tool, the next skill that you need to learn is the rounding of digits. Well, that's straightforward. And let me show you the proper method of doing it. Say, for example, we take some random number like 63.2. 63.7, 63.5, 73.5. Okay. Now I want to remove the decimal. I want to convert it into a proper whole number integer type. I want to get rid of, a decimal place. So whichever digit you want to get rid of, first see what the digit is. First see what the digit is. In this case, the digit that I want to get rid of is number 2. Here I want to get rid of 7. Here I want to get rid of 5. Here I want to get rid of 5. I want to get rid of these digits. Now, the first thing that you will check is whether the digit is more than 5, less than 5, or equal to 5. This two, like you can see, is basically less than 5. This 7, like you can see, is more than 5. Is more than 5. Here, this 5 is actually equal to 5. It's just equal to 5, obviously. Then comes the next step. If it is less than 5, then the previous digit or digits, keep it as it is. As it is, don't do anything. Hence, the rounded off number will be 63. Don't do anything to that number. But if it is more than 5, then you basically add 1 to it before writing it down. Hence, the nearest value to 63.7 will become 64. Just add 1 to it. If it is equal to 5, then check the previous digit whether it is odd or even. In this case, 3 is basically an odd number. So what you do, if it is odd, you add 1 to it and then write it down. So 63.5 is close to 64 as well as 63 equally. So you round it off to the nearest even number. So it will be rounded off to 64. When it is 73.5, which is equally close to 73 as well as 74, just check whether the number is odd or even. This number is basically odd, so you will make it as 74. But say for example, this was, let's say, like 78.5. This 8 is obviously an even number. You don't add anything to it, you just remain as it is. So 78 will remain as 78. That's how you do it. You make that number even. Is this absolutely clear? Now I will take it a step forward, and let's say you want to get rid of 2 or more decimal places. Like say for example, 23.567, 23.528, 23.550. And the question is, you want to get rid of 2 decimal places. So let me just show you what you want to get rid of. I want to get rid of 67 or 28 or maybe even 50. In this case, when you wanted to get rid of one digit, you are comparing it with the number 5, more than, less than, or equal to 5. When you want to get rid of 2 digits, what will you compare with? Obviously not 5, but it will be compared with 50, the number 50. Check this number 67, add 1 0, that's all. So this number is obviously more than 50, this is less than 50. This one is more than 50, and in this case, it's just happening to be equal to 50. So what you do is that in such situations, if it's less than 50, just like this one, if it's less than 5, as it is, right? So the previous digit goes as it is. So it will be approximately 23.5. Kind of makes sense. 528 is closer to 500 than 600. So that 5 remains as 5. Kind of makes sense. Look at this one. 567 is closer to 600. So basically you increase this digit by 1. That's it. So hence the answer will be 23.6. That's it. In this case, just check the previous digit. This one is an odd number. Whenever it is odd, you add 1 to it and then write it down. Hence it will be 23.6. If it was even, then you leave it as it is. Got it? I'm pretty sure many of you did not know this rule, especially when you had to remove 2 or 3 decimal places. Come on, I want to see whether you are thinking clearly or not. If we had to eliminate 3 decimal places or 3 places, What will you compare it with? Which number will you compare it with? Like we compared with more than, less than, or equal to 50. If I want to get rid of three places, what will I compare with? Everybody spam the answer in the chat box right now. What is that number? What is the number that you're going to compare it with? Yes, very good. Awesome. It's going to be 500. If you have to remove four places, it will be 5,000. If it is five places, 50,000. Exactly. That's all. That is the trick. The previous digit will be either as it is or added to 1. If it is equal to 5, either keep it as even. If it is odd, make it even. That's all. Awesome. You guys understood it. Thank you. Thank you. Very good, guys. I'm proud of you. And quickly smash the like button if you have not yet done that, because I keep things very simple while explaining to any student. I think of the student that a student does not know anything and only explain things. Okay. So if you love my teaching, thank you for liking and subscribing to the channel. Okay, let's say I want to get rid of, two places here. I want to get rid of two places over here. I want to get rid of this two places. What will you do? You will compare the 99 with the number 50. You will see that the number 99 is obviously more than 50. Is more than 50. So what will you do? What will you do, my dear wonders? You will take this number 4 and you will add 1 to it. You will add 1 to it. Hence, the approximate rounded off value will be 5 and then 5. And these two zeros will remain as it is. So you can just put it as 10 to the power 2, or you can just put it as 5500. 5500 kind of makes sense. 5,499 is obviously closer to 5,500. Let's say in this case, I wanted to get rid of only this decimal place. I wanted to get rid of only this decimal place. This number 3 is obviously less than 5. Then this number stays as it is. There is no change in that. So this will be 3, 4, 5. That's it. And put it as 0. This will be approximately 3450. Or you can also put it as 345 into 10 to the power 1. One and the same thing. Significant digits are maintained. Very good. Similarly, let's say I wanted to get rid of these 3 digits over here. These 3 digits over here. 405, you will compare it with 500. Obviously, it is lesser than 500. If it is lesser than 500, keep this number 4 as it is. So it will become 4000, which is as good as saying, or 4 into 10 to the power 3. So 4000 will be the nearest value to 4405, not 5000. Yep. Because 405 is lesser than 500. As simple as that. So that's how you play around with it. Let's take some more examples, my dear warriors, quickly. Let's see if you guys can figure this out. I want to get rid of 2 decimal places here. Here I want to get rid of 3 decimal places. Here I want to get rid of 1 decimal place. I want everybody to post the answers really quick. Come on. 2.656. Come on, my dear warriors. I won't do this on the board. I want your answers. What's the answer to this? I'm waiting to see your answers. Spam it right now in the chat box. Spam it right now in the chat box. Come on. 2.656. 56. 56 is more than 50. Come on. 56 is more than 50. If it is more than 50, take this digit, add 1 to it. That's it. So it will become 2.700. Yep, that's what it will be. But you're rounding it off. So you can put it as 2.7. Yes, you are getting rid of that 2 places. Exactly. 305. You're getting rid of 3 places over here. 3 places. You will compare it with 500. You will compare it with 500. Obviously, it is less than 500. The previous digit, keep it as it is. So it will just remain 2.000. But you're getting rid of this. So it is just 2. It is just 2. You're just getting rid of those 3 decimal places. In the last case, that number 4 is basically less than 5. So the previous digit will stay as it is. So 3.23. That's 0, but you're rounding it off. So it will be 3.23. 3.23. Exactly. 3.23. That 0 will have to be removed because I want to get rid of that decimal place. I want to get rid of that decimal place. Awesome. I'm getting rid of this. I'm getting rid of this. I'm getting rid of this and this. That's what we have done. Awesome. So you now have understood how to round. There was one more question. The number of numbers 3.845 and numbers 3.835 on rounding off to three significant figures will be how much? Three significant figures. Come on. Very straightforward. The numbers 3.845. I want to round it off to three significant figures. That means I want to get rid of the number 5. Now you can see the number 5 is equal to number 5. So you just need to check the previous one. This is even. This is even. So even stays as even. If you see over here, this is the number 5. This is basically odd. So whenever you have odd, you add 1 to it and then write the number. So 3.84, 3.84 guys. That's it. That is the answer. Option D. Option D. D for doctor. Awesomeness. Very good. Proud of all of you. Excellente, my dear students. D for doctor. Very good. Cool. Now let's understand how to combine the significant figures while addition and while subtraction. Okay. And while multiplication also and division also. Let's do all these things. Okay. So we're going to see how we are going to combine significant figures. So what do I mean by that? Let me explain. Imagine I have the numbers like 32.000 plus 4.0, or I have the numbers like 50.00 minus 10.0. I want to do this. Basically addition and subtraction. What will the answer be? What will the answer be? Just do the normal addition or subtraction. Just do value wise 32 and 4. If you add it, it's just going to be 36 value wise. 50 if you subtract 10 from it. So you're just going to get value wise 40. So value wise, this is the answer, but that is not the probably right answer by significant figures or decimal places. Whenever you have addition or subtraction, remember this rule. For addition or for subtraction, the final answer has the least of the decimal places. Has the least of the decimal places. So very, very simple. You can see this has 3 decimal places. This has 1 decimal place. 1, 2, 3. This has 1. So the final answer should also have 1 decimal place. Hence it will be 36.0. As simple as that. This also will have 1 decimal place. Understood? Straightforward? Okay. Let's say 50 minus 10, 40. You should see this has 2 decimal place. This has 1 decimal place. Hence this will be 40.0. 40.0. As simple as that. Imagine if there were more decimals here and maybe this had more decimals. Then again out of the 2, this has 4, this has 2. So the final answer should also have 2 decimal places. That's it. So this will have 2 decimal places because 2 is lesser than 4. So for addition subtraction, it's always the least of the decimal places. Now let's go to the next type, which is multiplication division type. So say for example, I have 8.00 multiplied by 2.0000. Okay. Or let's say I have numbers like 21.0 divided by 7.0. Okay, I want to find the value of this. Or 10.00 something. I've done some random things. Okay. For multiplication or for division, what is the rule? For multiplication or for division? For multiplication or for division, the final answer has the, again, the least, but not of decimal places, the least of significant figures. The least of significant figures. So very, very important. It has the least of the significant figures. Let's understand it right over here. First, set the value. 8 twos are 16, so value wise it has to be 16. 21 divided by 7, value has to be numerically 3. Then look at the decimal places. This has how many significant figures? 1, 2, 3. These zeros are significant. This has 1, 2, 3, 4, 5. 5 significant figures. So our final answer should also have how many? 3 significant figures. Already 2 are there. So hence, to maintain, balance it, I'll put it as 16.0. Do you understand? It's not a decimal. You can see decimal 2, decimal 4, so decimal 1. It's not the decimal places, but it is the significant figures which matter for multiplication and division. Exactly. Here, 21.0 has 3 significant figures. This has 1, 2, 3, 4, 5. So 3 is less. So 3 is the less of the 2. So final answer should also have 3 significant figures. So this one, 1, 2, 3. That's it. So this final answer also has 3 significant figures. Hence, this is the answer. Understood, my dear students, how this has to be done? 3.00 and 16.0. Yep. Clear? So for addition, subtraction, decimal is least. For multiplication, division, least of significant figures. So let's take some more examples for your sake. Let's say I do this. 9.000 multiplied by 2. Okay, multiplied by 2. How much is this going to be? Next, 40.0 divided by 5, or let's say 400.00 divided by 5.0. Okay, let's see if you guys can do this. First do it value wise, then check the appropriate answers. Value wise, 9 twos are 18. Value wise, 40 by 5 is 8, 400 by 5 is 80. Okay. But now check the appropriate significant figures, because this is multiplication and division. This has 1, 2, 3, 4 significant. This has only 2 significant. This has 1, 2, 3, 4, 5. 5 significant. This has exactly 2 significant. So our final answer in both the cases should have 2 significant figures. This already has 2 significant figures. Sorry, why did I put 2 here? My bad. This has 1 significant figure. My bad. This has 1 significant figure. So the final answer here should have 1 significant figure. Right now, this has 2 significant figures. So this can't be the answer. It has to have 1 significant figure. So you will have to round it off. You have to get rid of 18. 8. You have to get rid of 8 in that 18. So guys, this number 8, do you check this number 8? It is 100% more than 5. It is more than 5. So what will you do? You will take the previous number, add 1 to it, and then write it down. Hence it will be 2. You have got rid of it. Hence think of it like 20. So the correct answer to this, okay, this is the approximate. So the correct answer to this is 20, or 2 into 10 to the power 1. So 9 into 2 is 18. But understand, using significant figures and rounding off knowledge, it is actually 20. So if you show it to a lower grade guy, maybe a 6th standard or 7th standard student, they will be under shock. What are we even learning? But this is the correct answer. So if you want to scare the little kids out there, you can show them this problem. Shreyas Sir showed 18 is not the answer for 9 twos, but rather it is 20. Okay, because you have to round it off. This has 2 significant figures, whereas this final answer has 1, which is the correct significant figure. Here, this 18 Or, oh, wait a minute. This 0 is not to be counted. This has one significant figure. So this is not the correct answer if you write it down like this. No. So what will you write it down as is either 80 point. This is fine. Then you see there are two significant figures. Or you can also write it as 8.0 into 10 to the power 1. Okay. This is also correct. This is also correct. Both the cases, they have two significant figures. Both the cases, they have two significant figures. Both the answers are correct. Both the answers are correct. Got it? Everyone? You can also write this as 0 0.80 multiplied by 10 to the power 2. Just shifting the decimals and increasing the powers of 10. This also has two significant figures. If you notice, this 0 is counted as significant. Yeah, all these are correct answers if are there in the option. Very nice. Now, are you confident about significant figures, addition, subtraction, multiplication, division? Okay, we'll take a NCERT question. 5.74 grams of a substance occupies this much volume. Express the density by keeping the significant figures in view. Come on, think about it. Density means mass by volume. Density means mass by volume. Come on, do the division. See what is the actual answer that you get. Divide it. Come on, my dear warriors. Divide that 5.74, that is the mass, by your volume, which is basically 1.2. See how much do you get? Come on. 5.74 divided by 1.2. If you want, you can also do it as 12 and 57.4. It is one and the same thing. It's one and the same thing. How much is the answer that you are getting? How much is the answer that you are getting value-wise? Value-wise. 12 fours are 48. Come on, 2 goes with 7, so 9, 94. So 7s are, come on guys, 84. I think it will be 4.7 something. Somebody is saying 4.78. Come on, do it more, guys. Find it out till more decimal places. That can't be the correct answer. Okay, you have to think about the final answer also after this, because remember you have to round it off to proper decimal places and significant figures. Yeah, 4.78. What else? 3 will come, and I think 3 will be recurring after this. Yes, 3 will be recurring after this. This is the exact value. This is the exact value. Correct. But this can't be the correct answer to this. Why? Because if you see carefully, 5.74 has three significant figures. 1.2, basically, 1.2 has two significant figures. So 2 should be the final significant figures. So out of 4.7833, which is recurring, you have to get rid of this, all these things. So obviously 8333, it's closer to 1000 or 10,000 or whatever. So whatever the previous digit is there, you are going to add 1 to it to make it a proper rounded off number. So hence the answer will be 4.8. This will be gram per centimeter cube. Gram per centimeter cube. Let's find out. Yes, the answer is 4.8. The answer is 4.8. Understood how this comes? Is that clear? Yeah. 78 is closer to 80. You can see that. So obviously it has to be 0.8, not 0.7. That is the answer. How about this previous year, which was asked in 2020, the area given the length and the breadth, rounding off to the correct value. Obviously, area is length multiplied by the breadth. So area is 55.3 multiplied by 25. So this has 1, 2, 3. 3 significant figures. This has 1, 2. 2 significant figures. So area should also have 2 significant figures. Area should also have 2 significant figures. Out of all these options, I can only see this option D having 2 significant figures. This is not counted. This has 2 significant figures. This has more. I won't even solve it I just mark the answer as D. How many of you understood the trick? You don't even have to solve this. Imagine a person in NEET 2022 actually sat and solved this question, did this big multiplication, then did rounding off, and then checked one option, and then marked B. Such a waste of time. In such questions, use your brain. Only there is one option, and that's what the examiner is also looking for. Checking for the smart doctor. When you become a doctor, you have to be smart. You cannot be like, okay, in the book, it was written like this. So let me think. In the book, it was written this disease will come under this symptom. This symptom is there here. Okay. So then this should happen. Okay. Then that should happen. Okay. Then I have to do this. According to the procedure, I have to do this operation. And you realize the operation was not necessary. A smart doctor will be like, no operation necessary. You can just do this. There is a workaround like this. There was a case which I studied somewhere here, and you can do this, treat this particular disease in such a way. That will be a smart doctor. The patient will appreciate, and that doctor will become very famous. So that's what you need to become very soon. All right, moving on to the next part, which is errors. Is there anything in this world which is without errors? Probably nothing. If you talk about NDA, how many errors does NDA make? Probably quite a lot. How many silly mistakes do you make? Probably quite a lot. Anybody, anything, something, everything will always make errors. There is nothing which will not have a precise value. And this is a myth which young kids in school are taught. They are given a scale and they are asked to measure the length of something, or measure your height, or they are giving a weighing scale and ask measure the mass of this bag or something. And they're like, oh, the mass is 59 kg. Oh, my height is 170 centimeters. Oh, the time right now is, which have measured this for, it is exactly 8 seconds. This is impossible to give such precise numbers. Always there is some uncertainty, there is some error, there is some, probable range of values between which it lies. So very, very important, guys. Very, very important. So errors. So basically, any measurement, I'll write it down over here. Any measurement or calculation has some uncertainty, in it. This can arise due to the instrument. Like for example, I'm using a scale to measure some distance. It has some error because of those markings. They cannot be resolved beyond a certain limit. But if I'm using a microscope which has some markings on it which are more precise, then my answers are going to be even more accurate. So it depends on the instrument which I'm using. If I'm measuring mass of something using a weighing scale, and the masses which are given to me, standard masses are only in kilograms, I can't measure in grams. I can measure the mass of an elephant to some degree of few kgs here and there, which is okay, acceptable. But I can't say, okay, let me measure the weight of this gold necklace using those standard masses of kilograms. I need even more finite or very delicate masses. So it depends on the instrument or the method of the experiment. It also depends on the person. It depends on the person conducting the experiment. Like for example, if you give the same thing to a random Pandu, he does not understand how to measure mass. Something he has put, something it is doing, dancing, then only he has measured some value, or length he has measured some looking at some champa over there, then gone. That reading is inaccurate. So it depends on the person conducting it. It also depends on the method. Some methods of measuring are very accurate as compared to some other methods. You will see that. Okay, it depends on the method. It also depends on the environment. Environment. It also depends on the environment. Like sometimes, suddenly it is hot, and because it is hot, the scale only might become large. So you might get a different value. You are measuring the fever of a person, but maybe some pressure has changed, maybe some temperature has changed, maybe the scale has bent because of the atmosphere, because of some surrounding, and because of which the markings have gone little bit up or down. So you will measure a different value. So it depends on the environment. And lastly, it can be also random, completely random in nature. Some random thing happened. You were conducting the experiment very peacefully. Thunderstorm happened. You got scared, because of which you shook, and because of which the whole setup got shaken. But by the time you looked, everything looked fine, and then you measured the value. It was completely random. So it is out of your control. So all these things can happen, and this is a variety of reasons. Now, so whenever you write a reading, whenever you have a reading, the reading is made up of two parts. First part is basically your most probable value, most probable value, or the measured value, or the measured value, or the measured value, whatever you measure the length of something, or measure the time using a stopwatch. Okay, 5 seconds. Okay, 10 meters, whatever. And then you also have beyond it, you also have plus minus. You have the uncertainty in it. You have the uncertainty always follows it. Sometimes this is also called as the absolute error. This is also called as the absolute error. So there is a range of values between which any measurement or any reading lies. Any measurement or any reading lies. So just to give an example, if I ask Pandu, who has attended my class, his height, and this Pandu says it is 173 plus minus 2 centimeters, guys. So 173 might be his height. So if you think of a scale, Pandu's height. Okay, if you think of a scale, this is 0. Probably most probable value would be 173, but there is some uncertainty in it, plus or minus 2, plus 2 here, minus 2 here. So guys, there is a range of values from 171 to 175. It can be anywhere. So this is the range. This is the range in which the Pandu's height will be. It is not 176. It is not even 170.8. It is between that, but what it is, I don't know. It could be 172, it could be 171.1, it could be 174.89, but it is somewhere in between. Did you get that? Understand this concept, my dear warriors? Till this point, is it clear? What is the meaning of this? Any reading that you read is most probable value, the measured value, and plus or minus the uncertainty of it. This is how your final values are in most of the cases. Okay, now there is one serious doubt which I had got in my DNA batch from some students, and when I taught this chapter. Oh, by the way, I'm teaching this chapter also so that if you are considering joining the DNA 3.0 batch, it becomes easier transition for you, because that is the main chapter which I have done. So when you join also, like, okay, most of my backlogs are done, sir. Okay, because I'm just going to start off with motion in 1D in this particular week. So it will be very convenient for you to join the DNA 3.0. So one student asked me, sir, you are teaching me so many rules, sir, in significant figures, decimal places, and all of that. Do I have to use it for the rest of the physics, sir? So what do you think the answer is? I want to hear it from you. Do I have to use it for the rest of the physics while I'm doing magnetism, when I'm doing optics, when I'm doing modern physics, when I'm doing mechanics? Do I have to use these rules? The answer is no, unless it is asked to. If the question says find the answer to correct decimals or significant figures, then you solve it using these rules. Otherwise, when you're solving some chapter of optics, magnetism, something came, you are doing some calculation 2.305 multiplied by 2.9, and then you are seeing some answer, and then you are checking the options A, B, C, D, and then you are saying, okay, closest decimal, okay, this stuck. You will not check so much all the decimal places and all. You will just find the closest answer. You're not going to use these things unless asked for. Unless asked for. Keep this in mind. Okay? A lot of students have that doubt. It's only for this chapter you use. Yep. Ramu, I'll be taking up 12th standard topics of current, electricity, everything very soon. I want to do 1D and 2D at least, and then probably start off with your electrostatics and all that stuff. Is that okay? Now, like I said, absolute error. So, absolute error can be generally represented as delta A, then relative error, assuming this reading which you have, assuming this particular reading that you have is A, and then you have plus minus delta A. This is the value how you are measured, most probable. This is the uncertainty. This is absolute error, delta A. Relative error. Relative error means what? Relative error means what? Relative error is how much is the absolute error? That is basically delta A divided with the most probable value, which is basically A. That's what your relative error is. That's what your relative error stands for. Relative error means how much error is there relative to the main. This is that main reading. So how much error is there? Then you also have something called as the percentage error, where you multiply the relative error with 100. That's all, guys. Multiply this relative error with 100. That's it. That is your percentage error. Just to give you some examples over here. Just to give you some examples over here. If I tell you my length is, let's say 10 plus or minus 0.1 meters, then my relative error, is basically zero point 0.1, which is absolute, divided by basically 10, which is 1 by 100. 100. So if I measure 100, 1 is that uncertainty. It's very small, which is okay. If I ask you what is the percentage error, then your answer will be actual error divided by most probable value into 100. This is just going to make it as 1%. So the error is 1%, which is decent enough. Great. Awesome. Now, before we start problems, let's say there are many values and you want to find what is the most probable value and the error in. So, to find the error with multiple readings, imagine you are doing an experiment and your lab teacher has trust issues with you. My God, it is Savita and Naina and Dhayalakshmi in one group. Full danger girls. They will not do that experiment. I don't have trust. So I will ask them to take an average. Imagine Krishna, Pavitra, Ramu, right? And Avisha are in one group. My God, full trust issues lab teacher has. What will the teacher say? I have trust issues. I am going to suggest you a method. Use this method. I find an average and then come to me with the answer. So, whenever you want to find the error with multiple readings, this is the technique that we use. You take different multiple readings. You first take multiple readings. You basically take multiple readings. Like for example, R1, R2, like that. If there are n students, you take n readings. That's the first step of the problem. Whenever you have trust issues. This is trust issue. Next step after this, what you should do? You are going to add all these and find the average of them. You are going to find average. This is the symbol for average. Remember that. Either this or this. Whenever you put triangular brackets, it means average. You just add these R1 plus R2 like that till Rn and divide it by the number of measurements. This is the most probable value. This is basically your probable most probable value. Okay, just leave it like that. Next step, what you will do is, you are going to, after this, you are going to subtract this with this. Yup. Subtract this with the most probable value. And then what you get is how much difference is there between the most probable value and each reading. I will call it delta R in reading 1, change in reading 2, change in reading 3, like that, change in reading n. But don't just keep it like that. Find the modulus of it. Find the positive difference. Don't just leave it like that. Just take the positive difference. Each one of them, you are going to basically find the error in each or the deviation in each reading and find the modulus of it. So this is called as the absolute errors. Absolute errors in each reading. Next step, what you will do, once you have found this bit out, once you have found this particular thing out, you are going to take the average of them. You are basically going to take the average of them. So this is basically delta R's average value, which will be delta R1 plus delta R2 plus delta R3, like that, till the last whole thing divided by. This is the mean absolute error. Mean absolute error. Once you find this out, then comes the final step. Of the problem, guys. You have found this out and found this out. Hence the final answer. Will be this value, whatever you found over here. And then you will just put plus or minus this particular value. The errors modulus average. That is your final answer. So most likely the answer is this, but there is an error of this much. This is what you're going to write the answer as. These are the steps. I've shown you all the steps. We'll do a problem. Don't worry. Whenever you have multiple readings given in the question, add them, take the average by dividing by n. Find the difference positively, which is called absolute errors, absolute because mod. Then take the average of them and then write the final answer as this value plus this value. Is the steps clear? Let's do a question. Maybe. Probably you'll get the idea. Let's do this. The average absolute error for this problem will be how much? Come on. Let's do this problem. Come on. Okay. How many readings are there? 2.63, 2.56. These are some students who have taken these values. 2.42, 2.71 and 2.80. Okay. First things first, find the average value. Just see. Add these 1, 2, 3, 4, 5. 5 values are there. Add them and find the average of it. Come on. How much is it coming out? I'll use a calculator. You don't use a calculator. Okay. Here is my calculator. Come on, everyone. Just figure it out. Come on, my dear warriors. Yes. 2.63 added with 2.56 plus 2.42 plus 2.71 plus 2.80. Very good. It is 13.12. 13.12 divided by 5. Just check it out. It should be 2.624. Just check it out. It is 2.624. Perfect. But remember, you can't put so many decimal places. These are two decimal places. So you have to keep it to two decimal places only. So it has to be 2.6. 24 is closer to 20. So just keep it as 2.62. That is what we are going to leave it as. Is that right? Yeah, perfect. Next step. Find the difference of 2.63 with 2.62. Find the difference. Subtract this with 2.62 everywhere and just see what is the answer that you are getting and find the modulus of it. In this case, it is 0.01 if I'm not wrong. In this case, subtract 2.62 with 2.56. That's a difference of 0.6. Exactly, right? So 4 here and 2. Yes, perfect. Over here, 2.42 and 2.62, that's a difference of basically 0.2. Over here, yep, this is a difference of 0.2 because 42 and 62, the difference is 20. So it is 0.20 actually. So that's how I'll write it. 2.71 and 2.62, that's a difference of basically 0.09. Is that right? Lastly, 2.80 and 2.62, that's basically 0.18. That's the positive difference of all these numbers. That's the positive difference of basically all these numbers. Now you just have to take the average of these. Just take the average of these. Come on, 0.01 plus 0.06 plus 0.20 plus 0.09 plus 0.18. That's 0.54 divided by 5. That's 0.108. But I can't leave it in three decimal places. I have to leave it in two decimal places. 8 is a number which is more than 5. So the previous number I have to add 1 to it. So it will become 0.11. So it will become 0.11. Hence the correct answer is option B. Got it, my dear warriors, how this has to be done? Everybody? Cool? Very nice. Very nice. Can you now solve this question which was asked as a PYQ NEET 2023 just last year? 3.33, 3.32. Come on, my dear students. This was asked previously. So if you're wondering these kind of questions, do they come? Yes, they come. 3.33, 3.32, 3.34, 3.33, 3.32. Come on. Question is find the mean diameter to appropriate significant figures. Here you don't even have to find the positive difference and all of that. You just have to find the average. Here you just have to find the average. Come on. The average. That's all you had to do. Just add them and you have basically 5 readings. Just divide it by 5 and see what is the answer that you get. Come on, my dear warriors. Come on, my dear warriors. I'm going to do it by myself over here. Meanwhile, you also keep doing it. 3.33 plus 3.32 plus 3.34 plus 3.33 plus 3.32. These numbers divided by 5, that's 3.328. That's 3.328. But remember, I have to maintain the decimal places. I have to maintain the decimal places. In such cases, I have to get rid of the third decimal place. So 8 is more than 5. 8 is more than 5. So the previous digit, you add 1 to it. So that will approximately become 3.33. The 2 number becomes 3. So 3.33 is there as option C. Let's find out. Yes, it is correct. NEET 2023 question, guys. 3.33 centimeters. C for Captain Shreyas. Correct. Very good. Awesomeness. Okay. So you should know how many decimal places to keep and all those things. That's why we use those rules. I taught you those rules. Perfect. Now comes the next part where you might have to add, subtract, and multiply and divide errors. This is also fairly simple. You will see why. So let's start with addition subtraction. Imagine I have to add these numbers. 2.3 plus minus 0.1 plus 1.4 plus minus 0.5. Okay. Then another place, 7.00 plus minus 0.05. 2.00 plus minus 0.02. I have to subtract them. And I want to see what the answers are. For addition or subtraction, the rules are as follows. Remember these rules. For addition or for subtraction, the rules are as follows. Whatever the number is over here, do the normal rules. Use the normal mathematics. Basically, over here, 2.3 plus 1.4. 3 plus 4 is 7. 1 plus 2 is basically 3. So this is 3.7. 7 minus 2 is basically 5. Use the decimal places rule. So this has to have 2 decimal places. So this will be 5.00. This has 1 decimal place. So yes, 3.7 is also correct. There, you use your normal addition subtraction. The problem happens only for the later part. So for them, addition subtraction, the absolute errors get added always. Very, very important. They always will get it added. The absolute errors. Who are the absolute errors? 0.1 and 0.5. What is 0.1 plus 0.5? It is basically 0.6. What is 0.05 plus 0.02? It's basically 0.07. Do not subtract the errors. Only do subtraction or addition of these entities. These absolute errors are always added. Very, very important. Absolute errors are always going to be added. As simple as that. Is that clear? Everyone with me? Addition, subtraction rule, that is. Okay, perfect. Similarly, let's say they give you a question like this. There is a brick and whose length is maybe 5 centimeters plus or minus 1 centimeter. Then you put another brick whose length probably is 8 centimeters plus or minus 2 centimeters. You combine them together. You combine them together as one single unit. What will be the total length of it? Come on, my dear students. What will be the total length of it? 5 and 8. That's just going to be 13 plus minus. Absolute errors are 1 and 2. So it will be just 3. 1 plus 2 is 3. So 13 plus minus 3 centimeters is the answer. 13 plus minus 3 centimeters is the answer. Let's say another question. You have a bag full of maybe clay, rice, wheat, flour, something. And the weight of that bag is, let's say, 20 plus or minus 3 kg. 20 plus or minus 3 kg. Somebody comes and takes out some mass out of it. Somebody takes out. You take out how much mass? Let's say 5 plus minus 1 kg. How much is remaining is the question. How much is remaining? How much will this be? How much will this be? How much is the remaining part? So guys, the amount which will remain, what will you do? 20, you are taking out 5 from it. So 20 minus 5, that's 15, plus or minus. 3 and 1 will always add, it will become 4. So 15 plus or minus 4 kg. That's the answer. Exactly, 15 plus or minus 4 kg. Very good. So you understood addition and subtraction rule. Always the absolute errors get added. Now for multiplication division, there is no separate rule. Rather, I will tell you a generic rule. Not just multiplication division. In general, for powers. In general, for powers. What do I mean by in general for powers? Let me explain this with a simple example. Imagine I write kinetic energy is half mv square. Or I write velocity is displacement divided by time. Or I write momentum is mass into velocity. Or I write the time period of a pendulum is 2 pi root L by G. Any formula is combination of multiplication, addition and raised to some suitable powers. You write all these expressions in the numerator with those suitable powers. For example, in this case, half is a constant, forget that. M's power is 1, velocity's power is 2. In this case, there is no constant. Displacement's power is 1, time's power is negative 1. Momentum is mass raised to 1, velocity raised to 1. Here, 2 pi is a constant. L's power is half because root means half power. G is below. So the power of G is negative half. Negative half. You express it as powers. That is what I meant. In general, for powers. So, in general, what you can do is, in general, that physical quantity, express it in powers. Express it in some powers. So it will look something like this. The physical quantity is here. Some constant is here. P1 raised to alpha, P2 raised to beta, and so on and so forth. Just like I have done over here. Is this part clear? Okay. Do you notice this is actually division, this is multiplication, this is a combination of many things. So that is why I said not just multiplication, division. In general, I can use this rule, whatever I'm going to teach you. What is the next step? The next step is as follows. Take the relative errors and you add them by multiplying with the mod of the powers. Okay, let's understand what I just said. Take the relative errors. Relative error is error by the most probable value. Error by the most probable value. And so many more terms will be there. You take the power. In this case, the power is alpha, but take the modulus of it. Take the power, which is beta, but take the modulus of it. Same thing ahead. Just add them. Just add them. How many other terms are there? The final answer will be the relative error in the final quantity. There will be the relative error in the final quantity. That's it. That is the rule. That is the rule. So your relative errors get added and with the suitable powers. So over here, if I had to find the relative error in kinetic energy, it will be, forget the constants, m you take relative error, velocity you take relative error, power of m is 1, power of velocity is also 1. So 1 into delta m by m plus delta v by v. As simple as that. So this also means if m has 1% error, velocity has 2% error, this 1% will add with 2%, totally it will become 3%. So kinetic energy will have 3% error. Similarly over here, I can just write the relative error in velocity will be, take the power of s, it is 1 into delta s by s, plus take the positive value always, so 1 into delta t by t. So if this has 1%, this has 5%, 5% plus 1% will be 6%. So 6% will be the error in the velocity. That is what it means. Similarly over here, the error in our momentum, mass has a power of 1. So delta m by m, plus velocity also has a power of 1. So delta v by v. So if this was 0.1, this was 0.2, 0.1 plus 0.2 will be 0.3. So momentum will have an error of 0.3%. Similarly over here, the error in that time relatively will be, forget the 2 pi, L's power is half. So half delta L by L plus G's power is negative half, but like I said, take modulus. So it will be again half delta G by G. So this has 4%, this has 6%. 4's half is 2. 6 is half is 3. 3 plus 2 is 5. So time will have an error of 5%. That's how it works. Isn't this simple? But keep in mind, this only works. There is a small condition. This only works only if the error is less than 5 to 10%. It's better you keep it less than 5%, but till 10%, okay. Beyond 10%, you will see this formula will not work. This formula will not work. Okay, I hope this is clear. Oh, here by mistake I wrote it as 1 into. So sorry, thank you. I don't know why I wrote 1. This was 2 into. So velocity's power was 2, so we'll put 2 into. Okay, so always take the modulus. Like I said over here, modulus of the powers multiplied by the relative value. Okay, clear? Yes, thank you, Ram. Okay, let's do some questions so that we understand these concepts. The percentage error in the measurement of mass and speed are 2 and 3. How much will be the error in the estimation of the kinetic energy obtained by measuring the mass and the speed? Okay, let's understand it. Like we know, kinetic energy is half m raised to 1 v raised to 2. So the relative error in kinetic energy, forget the constant, is 1 into delta m by m plus 2 into delta v by v. Had I put percentage over here, this will be also percentage. Mass has a percentage error of 2% plus the velocity has a percentage error of 3%. 2 3s are 6, 6 plus 2 is basically 8. So the answer should be 8%. So 8% is the error in kinetic energy. As simple as that. Yes, B for biology, option B. Correct. Very good, Pratibha, Krishna, Srishti. Awesome. Everybody spam the answer, guys. Keep answering. Keep answering. Very good. Very good. Somebody saying B for IT Bombay too. Wow, we have J crowd as well. Okay. A physical quantity depends on the 4 observables A, B, C, and D. The percentage error in the measurements of A, B, C, D are as follows. The percentage error in Z is how much? You can see, we can write this particular Z in powers of these physical quantities by bringing them on the top. A raised to 2, B raised to 2 by 3, C raised to negative half, D raised to minus 3. So therefore, delta Z by Z will be 2 times delta A by A plus 2 by 3 times delta B by B plus half times, always take the modulus value, half times delta C by C plus 3 times delta D by D. That's all. So now substitute everything. Everything converted into percentage. A has a percentage of 2 plus 2 by 3. B has a percentage of 1.5, which is again 3 by 2 plus half into C has a percentage of 4. D has a percentage of 2.5. So how much will this be? This will be 4% plus 1.5 is 3 by 2. 3, 3, 2, 2 cancels. So it will be 1%. 4 by 2 is basically 2%. 2.5 into 3 is basically 7.5%. Correct? So 4 plus 1, 5, 5 plus 2, 7, 7 plus 7, 14. So it will be 14.5%. That should be the answer. 14.5%. Correct. We have got it. How many of you got the answer as 14.5? Come on, my dear warriors. Keep spamming the answer. Don't sit quietly. Okay. Let's go for the next question. It's a PYQ. So you see this class in RNA series, we do all kinds of questions, non-PYQs like concepts. We also do PYQs. We also do NCERT questions, if any. So this is how we keep the classes balanced. An electrical circuit has some voltage and current. What is the resistance? Okay. So we all know resistance is voltage divided by current. So therefore, resistance is voltage raised to 1, current raised to minus 1. Therefore, delta R by R is 1 times delta V by V plus 1 times delta I by I. Okay. Delta V. Voltage has an error of 4 amongst 200. Current has an error of 0.2 amongst 20. This 4 goes with 200, basically 50 times. So this will be 1 by 50. This will be going with it 100 times. So this will be 2 plus 1 divided by 100, which is basically 3 by 100. That is basically 3 by 100. Till this point, I hope everybody is clear. Okay. But be careful. We don't have to find the relative error. We have to find the actual resistance. So most likely the resistance would have been using this formula. Voltage, which was 200, most probable value, by the most probable current, which is 20, which is 10 ohms. So 10 ohms should be the most likely answer. 10 is there everywhere. So 10 is there here, 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 and here. Now look over here, guys. Look over here. We just saw delta R by R is 3 by 100. But delta R I don't know. R I know is 10. So this will be 3 by 100. 0, 0 cancels. So delta R is basically zero point 0.3 ohms. 0.3 ohms is right over here. Relative error led me to the calculation of the absolute error. So hence the answer must be option number B. Got it? B for biology. Yes. Understood how we got the answer? Clear? Very nice. Very nice. Let's do one more question, hopefully. Yeah, this was also PYQ. In NEET 2022, this was asked. See how easily you can solve it. Given that gravitational acceleration is 4 pi square L by T raised to 2, length and time are given. Find the percentage error in G. So now, obviously, G is, if you write it properly, 4 pi. You have L raised to 1, T raised to minus 2. So therefore, delta G by G will be 4 pi is a constant, ignore it, 1 times delta L by L plus, always take the mod value, so 2 times delta T by T. Now just put the values over here. What is delta L? What is delta L? Yes, it is 0.1. What is L? That is basically 10. What is delta T? It is 1. What is time? It is 100. This is a relative error, so this is 1 by 100 plus 2 by 100, which is 3 by 100. This is relative error. If I want percentage delta G by G, whatever I get, 3 by 100, you have to multiply it by 100. So hence the answer will be 3%, which is D. D for doctor or 𝐂𝐤𝐤. Correct. D for doctor or 𝐂𝐤𝐤. Very nice. Awesome. Very good. Wow. We have completed errors. Are you now thrilled for Vernier calipers and micrometer screw gauge so that we can ace this chapter like a king? Ready for it? Okay, let's do this. Remember when I said about errors, instruments also contribute in the errors apart from the person, the environment, and so much more. Very good. So, any instrument, any instrument has something called as the least count. Least count means basically the smallest measurement which can be made. And this basically contributes, this contributes to the absolute error in the reading. So for example, your normal meter scale, has a least count. This scale I'm talking about, your set square and all these normal scales, you can see it has a least count of basically 1 millimeter, which is also zero point 0.1 centimeter, which is also basically your zero point 0.01 meters. That is the least count. So using this scale, if I happen to measure, something as 5 millimeters, the answer will be 5 plus or minus 1 millimeter, because there is always this absolute error, the smallest measurement, the least count, which has contributed in that error. There is an uncertainty because the markings are only 1 millimeter apart. Or you can also say the some other reading, maybe let's say you measure and let's say the answer comes out as 0.7 centimeters. So it will be 0.7 plus or minus 0.1 centimeters. Let's say you measure something in meters and let's say it comes out as 1.56 meters. You can only measure till the second decimal. So plus or minus 0.01 meters. So the least count contributes to the absolute error. So depending on whether you are measuring centimeters, millimeters or meters, you will appropriately put that plus or minus 1 millimeter or 0.1 centimeter or plus minus 0.01 meters. Is this part clear? Okay. Every instrument has a least count. Excellent. Awesome. So now, why are we learning vernier and micrometer screw gauge? What is the reason? Let's say tomorrow I give you a task. Can you measure the thickness of your hair? Or can you measure the width of your skin? The thickness of the skin? Or can you measure how thick your nail is? Or if I ask you, can you figure out what is the bacteria size? Or what is the size of the xylem, or what is the size of this particular small part? So then you're like, I can't use the scale. I need a more precise measurement. I need a more precise instrument for that. So that's why we introduced two instruments. One is vernier, second is micrometer. Got it? So normal scale can only take you till millimeters. Vernier will take you to 0.1 millimeters, usually standard vernier. A more precise measurement can be done using micrometer, which will take you to 0.01 millimeters. That's what it is. So scale can only take us till millimeters. Just like if you are probably on your own, maybe you can reach a score of 600 with some effort. Maybe if you join a decent coaching, maybe you will reach to 650. But when you study under me, then it becomes very easy to score 700. So that's how it is. For more precision, you use a different instrument. For better score, you study under me, you study in Vedantu, need English. Exactly. So we have two instruments which we have to study. One is Vernier Caliper. This is how it looks like. 0.1 millimeters is the accuracy, usually. And then you have the screw gauge, which looks something like this, which you might have used in your lab practicals maybe a long time back. Awesome. Okay. Manoj, Vijay, this is not your dating app. Concentrate on the class. Sir is there. You are concentrating on Divya. Divya is concentrating on NEET. Other students are concentrating on NEET. What is this? To concentrate on the right focus, no? Just because somebody will go to medical college, you will not follow your girl over there, no? You have to get entry. The guard and the watchman will shoo you away. He'll ask your NEET score. If your NEET score is 500, how will you go into AIMS? Everybody else will go into AIMS. You know? So if you want to follow, you have to not follow the girl, you have to follow NEET. Understand that. Then you can do whatever you want in the campus. Yes, NEET note ko samsa. Okay. Now, where are we? Yes, let me go back. Vernier Caliper. Okay. So let's say you want to measure my width of the head. So what you will do, you will place my head somewhere here like this. and these two things which are there, which are movable, you put it like this so that you can measure the width of my head. Okay, that is how it is done. Correct. If you want to measure how wide Shreyas Sir's mouth opens, then you use this, not this. Yeah, I'll stand like this. And these two things which are there, you'll open it up. You'll open it up, and they will measure the inner width. So these are used for measuring inner dimension. This is used for measuring outer dimension. You want to measure my head width, you will place this here. You will place this here. And if you want to measure the width of my ear hole, or probably how wide Shreyas Sir's mouth opens, I will stand like this and you will open it up like this. Understood? Very good. You have two scales here. One is the main scale. One is the main scale. Always in these two instruments, you always have a main scale and an auxiliary scale. That auxiliary scale, because the name is vernier, it is called vernier scale. Main scale and vernier scale. On this also there are markings. On the main scale also there are markings. You will see the same thing happens even in screw gauge. This, if you want to measure how wide is Shreyas Sir's finger, I will put my finger here. I'll put my finger here, and then you will rotate this till these two things touch me. And the moment they touch me, I'll be like, ouch, it's hurting. Stop it, guys. And then you will measure the value. That's how it is done. Understood, guys? Very good. So there is a main scale. I don't know whether you can see it clearly here, but there is a main scale, and the one which rotates is called as the circular scale. The image is not very clear. There is a scale here. It goes on like that. And then there is a circular scale, which is your auxiliary scale. Perfect. Now, whenever you have a vernier caliper or micrometer screw gauge, the first thing which you will generally need is the least count of it. What you will generally need is the least count of it. So how do you find the least count? Okay, the logic goes like this. If you have OCD, to explain your least count, if you have OCD, that is the best example. OCD means obsessive compulsive disorder. Means you want things in that place only. For example, you keep the mug or your glass in this place. If it is fallen here or there, you don't like it. You get irritated. What is this? Why is it like this? If you put a carpet, it has to be aligned with the walls of the room. If the carpet is at an angle, you will get irritated. What is this? Why is it like this? Right? Shreyas Sir also has partial OCD. Shreyas Sir draws lines like this. Shreyas Sir is very happy. Shreyas Sir draws lines like this. Shreyas Sir is very unhappy. I don't like this. Even though I can draw the graph, I am not very happy. So Shreyas Sir also likes the presentation to be nice and clean. Same way. Imagine you have some tiles. Imagine you have some tiles like this. Each tile has a width of 3 meters, 3 meters, 3 meters, 3 meters, 3 by 3. The neighboring row of tiles is not 3 meters. It is 4 meters. Slightly longer. Slightly longer. So it will be something like this. It will be something like this. Something like this. Probably something like this. It will be something like this. This is 4, 4, 4, 4, 4. So you will see the alignment will go off. Have you seen the alignment has gone off? Yeah. The alignment has gone off. Correct. But you saw one interesting thing. They started together. They started together. There was a slight mismatch, match. They matched. Oh, and where did they match? They matched after their LCM. LCM of 3 and 4 is 12. LCM of 3 and 4 is 12. So basically this is 12 units. If you notice, 4 actually I have not put it properly. It should have matched here. I didn't put it properly. It should have matched at 12. So maybe I should draw it, redraw it. Maybe it will match here. Yeah, it will match here. Yeah, you will need 4 tiles of 3 and you will need 3 tiles of 4. So they will match after the LCM. Is that right, everyone? Great. So this is actually the working principle of a vernier caliper. Exactly, this is the working principle of a vernier caliper. So what happens in a vernier caliper is on the main scale, you have some markers. 1, 2, 3, 4, 5, 6, 7, 8, 9, let's say 10, 11, 12, and this continues. Let's say this is 0, this is 10, this is millimeters by the way. Okay, everything is in millimeters. What you have is the vernier scale. You have the vernier scale, which is having slightly different width of divisions as compared to the main scale. Imagine there are 10 divisions here on the main scale in 10 millimeters. Imagine this has basically, imagine, more number of divisions in lesser meters or lesser length. Let's say for example, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 0. This is 10. You can see the width of each division is different. The width of each division is different. And that is why you can see this number 10 is not matching with this number 10. It is, finishing off before only. It is finishing off before only. Are you able to see that? Because the width is different. So this is how exactly like how those tiles were arranged. In this case, each division of the main scale, one division of the main scale was exactly 1 millimeter, 1 millimeter, 1 millimeter, 1 millimeter, 1 millimeter, 1 millimeters. You can see that 10th division of the vernier scale coincided with 9th division. This is 9th division of the main scale. With the 9th division of the main scale. That means this length was actually 9 millimeters, which was divided in 10 parts. So if you ask me how much is one division of the vernier scale, the answer will be how much is one division of the vernier scale? This is 9 millimeters. It's divided in 10 parts. So 9 millimeters, I will divide it by 10. So it will be 0.9 millimeters. As simple as that. It is basically 0.9 millimeters. Everybody with me? Understood? This whole length was 9 millimeters. Remember, this is actually 10 millimeters. This is actually 9 millimeters. The 9th division of the main scale is coinciding with the 10th division of the vernier scale. This is not millimeters. This is not millimeters. This is millimeters. This is slightly off scale. So each division over here will be 9 divided in 10 parts. So that's 0.9 millimeters exactly. So then comes your final answer of the least count. The least count of a vernier caliper is always the positive difference between this number and this number. Whichever is bigger, whichever is smaller, doesn't matter, guys. 1 millimeter and this is, let's say, 0.9 millimeters. You just take the positive difference. The answer, whatever you get, is the answer. So it is 0.1 millimeters. This is the least count of the vernier caliper. This is the least count of the vernier caliper. If you are wondering why is this least count, let me explain. just look at this small region over here. Look at this small region over here. This was your main scale. This was 0. This was 1 millimeter, 2 millimeter, 3 millimeter, 4 millimeter, 5 millimeter, like that. On the vernier side, this was 0. This was like this was like this, and so on and so forth. See, this much distance was 0.9 millimeters. This much distance was 1 millimeter. Now do you see this gap which is there? Now do you see this gap which is there between these two lines? Do you see the gap between these two lines? This gap, how much will it be? 1 minus 0.9, which is basically 0.1 millimeters. Which is 0.1 millimeters. So if I move the pink scale left, right, I can make this pink line coincide with the yellow line. I can make the pink line coincide with the yellow line. Once it coincides, how much I have moved the pink scale? How much have I moved it? If the pink line coincides with the yellow line over here, I have moved it by 0.1 millimeter. So I can make those precision movements. If I match this pink line with this yellow line, I would have moved it by 0.2 millimeters. If I move this line with this line, match them, I would have moved it by 0.3 millimeters. So by moving these lines, I can move it by an increment of 0.1, 0.1, 0.1 millimeters. Hence, this 0.1 millimeters is the least count. Understand that. So, had I moved this, I'll just show it to you right over here. 1, 2, 3, like that. I would have moved this scale so that they coincide like this. You can see they coincide. And how much I have moved it by is exactly 0.1 millimeters so that they coincide. That is how the least count measurement happens. Oh yeah, happy Doctor's Day to all of you. I forgot totally about it to wish all of you happy Doctor's Day, guys. Today is Doctor's Day. And actually you should be saying happy future Doctor's Day because you're going to be future doctors, right? Okay. So how is the least count calculated? You basically, I will tell you a very simple way. Use one division of the main scale. Use one division of the vernier scale. Subtract the two. You will basically get the least count. So the least count of vernier caliper is the positive difference of one division of main scale minus one division of vernier scale. That is the formula for least count. Is this point very, very clear? Can we do a question on this? Can we do a simple question on this? Let's see if you guys can do a simple question on this. 1 centimeter of the vernier caliper is divided into 10 parts. 10 divisions of the vernier scale coincide with 8 divisions of the main scale. The least count of the caliper is how much? Okay, let's write this down. 1 centimeter of the main scale is divided in 10 parts. Look at this data. 1 centimeter is basically 10 millimeters. You are dividing in 10 parts. Basically 10 divisions. 10 divisions of the main scale. Therefore, one division of the main scale will be how much? One division of the main scale will be how much? 1 millimeter. That is the first important data which we got. Next data. 10 divisions of vernier scale. 10 divisions of the vernier scale coincide with 8 divisions of the main scale. What does it mean? Let's understand. 10 divisions of vernier scale match with 8 divisions of the main scale. But one division of the main scale is 1 millimeter. That means it corresponds to 8 millimeters. But that is 10 divisions of vernier scale. If I ask you how much does one division of vernier scale belong to? You take that 8 divided with 10 parts. 8 divided by 10. How many millimeters will it be? It will be 0.8 millimeters. Is that so? It will be 0.8 millimeters. Last thing is basically your least count. What is the least count formula that I gave you? What is the least count formula? One division main, one division vernier, subtract the two, take the positive difference. One division main, one division vernier, 1 millimeter. This is 0.8 millimeter. How much is the answer then? It is basically zero point 0.2 millimeters. It is basically zero point 0.2 millimeters. Where is it? 0.2 millimeters is not there, but you can convert it into centimeters. You will 0.02 centimeters. So it is option number B. Option number B. Understood, my dear students? How to solve these questions? So main thing is first to identify what is the least count. Very good. Now, same thing can be done for the screw gauge also, but it works slightly in a different manner. In a screw gauge, if you rotate it once, it goes forward by some amount. You rotate it once, it rotates, it moves forward by one amount. If you rotate it reverse, it goes behind by that same amount. Okay, just imagine one nice, beautiful champa who turns around and moves forward towards you, but she sees you and she's like, oh my God, what is this? And she turns back and she moves exactly away from you. Champa sees you from a distance, Champa rotates, she turns and comes towards you and looks at you, and then she's like, oops, and she goes behind. So when you rotate once, how much you move ahead by is called as the pitch. Is called as the pitch. So imagine there is a champa and that champa rotates once, twice, and she comes towards you, looks at you. She rotated twice and she moved by 10 meters. So per rotation she had moved 5 meters. One rotation 5, another rotation 5. So Champa's pitch is 5 meters. Champa's pitch is 5 meters. Per rotation, how much do you move? That concept is used over here because when you take a screw and rotate it, it moves forward or backward. So you rotate it, how much does this move? So this entire thing will press against. Remember, my finger was stuck here. I hope you remember this. My finger was stuck here. You rotate this thing will move back and forth. It will move back and forth. My finger was stuck over here. Yes. So that is called as the pitch. So what is written on this rotating scale, the circular scale, are some divisions, some number of divisions, 100, 200, 500, 700, whatever. It moves by certain amount after a rotation, which is the pitch. So for one rotation, imagine Champa rotates once and the pitch of Champa is 5 millimeters. Champa rotates once, her pitch is 5 millimeters. In that one rotation also, if I put markings, imagine Champa is like a clock. Champa has some markings on her. And then she's like, okay, if I rotate once, I have 50 markings on me. 50 markings will go round. So in that one rotation, if I move by 5 millimeters and if I have 50 markings on me, think about it. One marking will be how many? How many millimeters? If I rotate completely 50 markings, it is 5 millimeters ahead. So if I just rotate one marking, how much will I move ahead by? If I rotate by one marking, how much will I move ahead by? Think about it. Think about it. 5 millimeters, 50 markings. One marking, 5 millimeters divided by 50. 5 divided by how much? 50, which is 1 by 10, which is 0.1 millimeters. So Champa will move by 0.1 millimeters ahead. Got it? Understood? Excellent. Excellent. Very good. 0.1, not 0.5, 0.1. 5 millimeters for 50. So for one marking, how many millimeters? You take 5 divided by 50. So you will get per marking 5 by 50, which is 1 by 10, which is 0.1. That is the least count. What is it? That is the least count of a micrometer screw gauge. So, first we defined the pitch. First we define the pitch, which is the distance moved by the screw upon the number of rotations. I gave you the example of Champa. Champa rotates 2 times for, let's say, 10 millimeters. So the pitch of Champa will be her distance moved 10 millimeters. How many rotations? 2. So it will be basically 5 millimeters. That would be the pitch of Champa. In the screw gauge example, it will be given to you how much it moves for how many rotations. So then comes the least count. So what is the least count? The least count. The least count will be as simple as you first find the pitch. First find the pitch divided by the circular scale divisions. Divided by the circular scale divisions. In the example of Champa, I told you that there were 50 divisions on circular scale for 5 millimeters pitch. For 5 millimeters pitch. So then what will your least count be? Your least count will be 5 millimeters. 5 millimeters divided by 50, which was 1 by 10th of a millimeter, which is 0.1 millimeter. That's how you can find the least count of it. Is that clear? Okay. Let's take an example on this. This is directly a PYQ. I think we can go about it. A screw gauge has a least count of 0.01 millimeters and there are 50 divisions on its circular scale. The pitch of the screw gauge is. Okay. Here, least count is given, pitch is asked. Interesting. We all know least count is pitch divided by circular scale divisions. The least count itself is 0.01. The pitch is unknown, which is what we have to find. And there are 50 divisions on the circular scale. So therefore, how much will that pitch be, guys? How much will that pitch be, guys? Come on. What is the answer? Everybody spam it. Everybody spam it. It's so simple now. Yes. How much is it? Very good. Come on, my warriors. 0.5. B for Baswa sir. B for biology. Very good, guys. Very good. This will be 0.5 millimeters. Amazing. Where is it? B for Baswa sir. Excellent. That was asked in NEET 2020. Can you believe that? That was the kind of question which was asked. Amazing. Okay. Now, more questions are there, but for that, we need to study more. So, we understood how to find least count. Whether it be Vernier Caliper or whether it be micrometer screw gauge. Now, let me tell you how to find the reading. See, imagine this is your main scale. And your vernier scale is somewhere here. This is just an example. Let's say the least count is 0.1 millimeters. This is the least count, which is 0.1 millimeters, and they ask you what is the reading of it. They ask you what is the reading of the vernier caliper. What you will always do is number one, first find out something called as the main scale reading. What is this main scale reading? Observe this carefully, guys. What is this main scale reading? Main scale reading is basically which number has the zero of the vernier crossed for the main scale. The number zero of the vernier scale has crossed which number of the main scale? It has crossed the number 18. So this is basically the main scale reading. What is the main scale reading? The zero of the vernier would have crossed some number. That is your main scale reading, number one. Number two, you will find the vernier scale reading. You will also find something called as the vernier scale reading. So what is this vernier scale reading? Check the vernier caliper, check the divisions, which division is coinciding with some division of main scale. Don't see main scale number, just see where is it coinciding. I think it is coinciding here. Here it coincides. Don't measure for the main scale, measure for the vernier scale now. 1, 2, 3, 4, 5. This is the fifth division. So this is the vernier scale reading. Got it? Now what you do is whatever vernier scale reading is there, multiplied by the least count. What is the least count? The least count is 0.1. Finally, what you're going to do, just add them. That will be your answer. That will be your answer. That's it. So it will be 18.5 millimeters. That is the answer. 18.5 millimeters. Got it? That is how the reading of a vernier caliper is taken. As simple as that. So let me formalize it here. The main scale reading, whatever is there, main scale reading plus you will take the vernier scale reading plus you will take the vernier scale reading multiplied by the least count, add it, what you will get is the final answer. What you will get is the final reading. Main scale reading plus vernier scale reading into least count. But that's not all. That's not all. Sometimes there might be something called as zero error. Meaning already the vernier caliper before you started measuring only had certain movement. Imagine something like this over here. Initially only the vernier caliper shows this. Before putting anything, before placing anything, already it is showing 0.1 millimeters. You can see it has crossed the 0th division, so it is 0.1 because first division is crossing over here. So then whatever I measure will have some error that is called as zero error. What is it called? Zero error. Another example for zero error. Whenever you measure the weight, what do you ensure? Zero is there or not on the weighing scale? Only then you stand on it. Imagine before you stood on the weighing scale, it already shows 1 kilo. When you stand on it, it shows 70 kilos. So is your weight 70 kilos? No. Already it showed 1 kilo. So when it is showing 70, that one which was already being shown, you will subtract it. Actual mass will be 69. Same way, when you are filling fuel, what do you ensure? Always ensure zero before filling the fuel. So same way, guys, you need to ensure that whether it is showing zero or not. If it is not, we'll subtract it. Maybe the person filling the fuel, okay, already it is showing some 200 rupees, and you ask the petrol to be filled for 300. He will only fill for 100 rupees and demand 300 rupees from you. That's cheating. Already it was showing 200. Now you filled it till 300 rupees. So you just have to pay for 100 rupees. So that's why you need to accommodate for the zero error. So there is always some kind of zero error which might be there. There might be some kind of zero error which might be there. That is the reason why you will have to either add or subtract the zero error. You will always have to add or subtract the zero error, depending on whether it is more or whether it is less. I am very cool. I am very good. Now, always keep in mind, whenever it is positive error, then you are always going to subtract. Whereas whenever it is negative error, you are always going to add it. Very, very crucial. Whenever it's positive error, always take it out. Whenever it is negative error, always add it out. Like for example, when you talked about the weighing machine example, nothing was there. It shows 1 kg. That's a positive error. It's showing 1 kg. Positive error. So when you stand and measure 70 kilos, you will subtract 1 from it. So that was a positive error. Let's say before standing on the weighing machine, it was showing minus 2 kg. It is showing negative 2. So if you place something, then it becomes 0. If you place something, then it becomes 0. Some small mass. So that is a negative error. So if it was showing minus 2, and then when you stand on it and it shows 70, so you are going to add 70 with the number 2. 70 plus 2 will be 72 kilos. So your actual mass will be 72. Understood how the negative and the positive errors work? Understood everybody? Clear? Yep. It's exactly opposite. So keep this formula and this particular formula in mind. These are the most important formulas. Most important formulas. Let's do some question based on this. What do we have? Find the zero correction in this figure. Question is, find the zero correction in this diagram. Okay. Just see what is the main scale reading first. Okay, it has crossed 0. The 0 of this has crossed the 0 of this. So this 0 is the main scale reading. Okay. Remember our formula, main scale reading plus. Then you have the least count. Least count of this. Oh, we need to find that out. I think it will be 0.1 millimeters. Again, it's the standard thing. Okay, it's the standard thing, 9 millimeters and all of that. So the least count, I believe, will be again 0.1 millimeters only. The main scale reading is again 0. Oops. 0 millimeters plus. You have to multiply the least count with the Vernier scale reading. Just check which division is coinciding. I can see the fifth division is coinciding. Fifth division is coinciding, guys. So I will multiply by the Vernier scale reading, which is basically 5. Hence, the final answer to this will be 0.5 millimeters. But will it be positive or negative? Will it be positive or negative? Let's see how many of you can get this correctly. Will it be positive or negative? What will you do? This is already ahead. So hence, this is a positive error. Exactly. So the correction, remember the question is find the correction. The correction will be negative. So you will subtract 0.5 millimeters. Read the question. Find the zero correction. The error is positive, so the correction will be negative. So the answer is negative. So the answer is negative 0.5. How nice and tricky the question is. How nice and tricky the question is. Understood? Clear? It's a positive error, but the correction will be negative. Just exactly what I told you over here. For positive error, subtract. That's the correction. For negative error, the correction is you have to add it. Nice. Let's look at the next question. I think by mistake, circular scale. So it's supposed to be for micrometer. Okay. Anyways, this least count was fine. We did this. Okay. Now, for the reading of screw gauge, This is very, very similar. This is very, very similar to the Vernier Caliper. Main scale reading plus least count into Vernier scale reading. Same way, what you will do is the reading, for the reading, same way, guys. First, you will measure your main scale reading, main scale reading. Then to that, you will add the least count multiplied by the circular scale reading, and towards the end, whether there is zero error or not, you will basically correct it accordingly, plus or minus. This is the formula. Instead of Vernier scale reading, you just have something called as the circular scale reading. That's all the difference is. So how it works is, imagine this is your circular scale, and let's say this is that main scale markings. It has some markings over here. Let's say this is 30. Let's say this is 30. It's showing like this. And over here, this has, let's say, a least count of 0.01 millimeters. There are many divisions on it. Let's say this is 40. Okay, and this continues 41, 42, 43, 44, 45. Okay, this is 45, something like that. This is how it looks like. So, what are your different readings? First of all, your main scale reading. Your main scale reading is that number which is clearly visible and which has just been crossed by the other scale. So 30, 31, 32. So it will be basically 32 millimeters. Then next comes your least count. What is your least count? Already given 0.01 millimeters. Add it, but multiply it also simultaneously with the circular scale reading 40, 41, 42. So multiply it by your circular scale reading. So multiply it by 42. That's it. So this will be 32 plus 0.42. Hence the final answer. Hence the final answer will be 32.42 millimeters. That is the answer. 32.42 millimeters. Is that clear? Everyone? If diagram is given, how can we find whether it is positive or negative error in screw gauge? In the diagram, how do you know whether it is positive error or negative error for screw gauge? I'll show it to you very simply. Yes. Because the circular scale is ahead, zero is visible. This is basically your positive error. The correction for this will be to subtract. Here, zero is hidden. It is not seen. So this is negative error. And in this case, you will basically add. That's the difference. If zero is hidden, it is negative error, you will add. If zero is visible, you already moved ahead. That's positive error, you are going to subtract. Okay? Understood? Sir, for all the sums, should we take 0.1 as the least count for Vernier? Ramu, if it is not given to you what the least count is, then you will take it as 0.1. If it is given to you, then you will calculate it based on the given information. That's how it works. Cool. So let's do some questions based on this. Come on. So we have been shown some diagrams. Interesting thing to note, there is already some zero error. The circular scale has 50 divisions, moves 0.5 millimeters on the main scale in one rotation, diameter of the ball is. First things first, find the least count. Remember, to find the least count, what do? You take the pitch and divide it by the circular scale divisions. What is the pitch? It moves 0.5 millimeters in one rotation. Basically, this exactly is the pitch. In one rotation, it has moved 0.5 millimeters. How many circular scale divisions are there? On the circular scale, there are 50 divisions. So this will be 1 by 100, which is 0.01 millimeter. That is your least count. Keep it on the side. Keep it on the side. Now, let's calculate the zero error over here. Do you see this zero is shown, so it is a positive error. Zero on the main scale is seen, so it's a positive error. The number on the circular scale is 5. I hope you are able to see it. Maybe on the big screen you will be able to see it. The number on the circular scale is 5. So the zero correction or the zero error which I will have will be main scale reading 0 plus least count 0.01 multiplied by the number on the circular scale is 5. So hence it is 0.05 millimeters. It's a positive zero error. It is a positive zero error because zero is seen. So it is an error of 0.05 millimeters. Next thing. Here, the reading which I get. What is the main scale reading? Check it out. 0, one more division. So 2 divisions are seen. So 2 millimeters on the main scale plus least count. What is the least count? It is basically 0.01 millimeters multiplied by your circular scale divisions. 20, 25, 30. I can see 25 over here. So what is this going to be? 2.25 millimeters. Is that right? 2.25 millimeters. But do not forget there is zero error in it. So I have to subtract that thing which is 0.05. I have to subtract 0.05. So final answer will be 2.20 millimeters. 2.20 millimeters. I think I have asked the diameter of the ball. Why have I put 1.20? It should be 2.20. It should be 2.20. Unless they meant each division is. Oh, I made a blunder. Yes, I'll tell you what. It moves 0.5 millimeters in one rotation. This is the catch. It has moved 0.5 millimeters, and this is a very common mistake which students also do. So in one rotation, remember one division will be moved. So now here 2 divisions are seen. So actually, when 2 divisions are seen, 0, 1, 2, actually that is not 2 millimeters. Each division is 0.5, 0.5. So actually it is 1 millimeter. Understood? So the main scale reading is not 2 millimeters. Actually it is 1 millimeters. Does that make sense? And the remaining thing stays as it is. Plus the least count, which is 0.01 millimeters multiplied by circular scale division. Circular scale division is basically 25. And we have to subtract the zero error, which is 0.05 millimeters. So what do I get? This is nothing but 1.25 millimeters, which is 1.25 millimeters minus 0.05 millimeters. So when you subtract these two, you'll get 1.20 millimeters, which is option number 3. That is the correct answer. Yeah. So you need to be sometimes careful. The pitch, whenever it is not 1 millimeter, 1 division won't be 1 millimeter. 1 division will be zero point 0.5 millimeters. So actually, when two markings are shown, the length will be 1 millimeter. So you need to be a little bit careful over there. Got it? Clearo? Shall we go ahead to the next one coming up on your screen? Here it is. Find the thickness of the wire. The least count is 0.01. The main scale reading is in mm. So already mentioned, main scale is in millimeters, not 0.5 millimeters. Okay. I can see some zero error is there when the jaws are clamped, but when you place that object, then it is showing some reading. So obviously I have to subtract that, only then I'll get the answer. Okay, let's see what is the zero error in this case. This zero error is positive zero error, because I can see the zero. If I could not see the zero, it would be negative zero error. What is the main scale reading? Main scale reading is 0 plus least count 0.01 multiplied by, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think the third 1, 2, 3 third division is coinciding. Can you see that? Third division is coinciding. I hope you see that. So hence the answer will be 0.03 millimeters. That's the zero error. Let's see the reading here. Let's see the reading here. What is the main scale reading? Everything is in millimeters. 1, 2, 3, 4, 5, 6, 7. It has just crossed 7. Seventh is barely seen, so it is 7 millimeters. Plus, what is the least count? Least count is 0.01 millimeters. Do not forget to multiply it with circular scale reading. 60, 61, 62, 63, 64, 65, 66. Ooh. 67, 68, 69, 70. Okay. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. It is 7th reading. It is 7. So basically 67th. It is basically 67th reading. I hope you can see that. It is 67th reading. Yep. So what will be the answer for this? This will be 7.67 millimeters. But we have a task at hand. You have to subtract 0.03. You have to subtract 0.03 millimeters. Yeah. Only then you'll get the correct answer. So this will become 7.64 millimeters. 7.64 millimeters, which is option C. Which is option C. Got it, everyone? Everybody, C for Captain Street. It's not 7.65, 7.64. Yeah, you have to subtract this over here. Positive error, subtract. Negative error, add. That's why I subtracted it. Awesome. Now, do you have confidence on verniers and micrometer screw gauge? You will be able to solve these questions. Anything is given, you will directly be able to solve it, my dear students. So chapter 1, have you rocked it or not? Do let me know in the comments after the video, not just in the live chat, but in the comments too. And how many of you know that today we are starting off with the DNA 3.0 batch? Yes, today is the entry point, and you will see our lectures being scheduled in the DNA batch. Now, where is this DNA batch? I'll show you. Where is me first? This is me. And where is description? This is the description box when you click more. And you can see DNA 2025 NEET batch in English. This batch, third entry point, not many chapters done, plus the backlog coverage will help you with it. Don't worry. Remember, the results are out for the re-NEET, and we saw not much change. And it was expected also. It won't change much. That's why if you are interested in preparing for 25 or 26 in English, batch has just started with assignments, with test series, with DPPs, with books, with coaching module, with mock tests, with all India ranking, as well as lots and lots of study material. All of this in pure English with your favorite YouTube teachers and HODs of respective subjects in the course. This price is 3,999 right now, but it will change as soon as our entry point for 3.0 will close. I'm just keeping it open because the results were declared today. But other than that, we will say this price will immediately go up to 5,000 rupees within no time. So make use of this right now. You just need to click on buy full course and you will see the coupon codes, everything has been applied. You have multiple options. Every single detail regarding the DNA batch has been given to you over here, right over here. Just few days back, I made a beautiful video explaining you all the features in detail. There's a 23-minute long video. You can check that video out. You will get to know everything. Okay, so make that decision, make that choice wisely because a lot of students, 1,000+ students, are already a part of this DNA batch. So, my dear warriors, if you don't want to miss out on what they are getting, because these 1,000 students plus are going to rock in NEET 2025, you don't want to be behind them. Make the full use of this. Okay, that is your DNA batch on the paid platform and you have your RNA batch on YouTube. So thank you so much for watching. Thank you for liking. Thank you for commenting as well. Bye. Take care, Captain Shreyas signing off. As always.